Hey guys, welcome. Here's a short introduction to atomic structures, a quick revision. So if anyone missed it or if they want a quick revision, here's a short set of videos on atomic structure. If you remember from our first chapter, we talked a lot about kinetic theory of particles, and we talked, a lot about particles. So we're going to study a lot more about these particles, and these particles are called atoms. An atom is known to be the smallest form of matter that exists, right? Smallest particle of an atom, and we cannot break it down any further by any chemical means. Okay? So it's just the smallest particle possible. And what is it made of? What does it look like? So it's made up of three subatomic particles, which are the electrons, the protons, and the neutrons. I haven't written that here, but the electrons, protons, and neutrons. So the protons and the neutrons are right in the center, right? They like to stay right in the center, and electrons zip around it, and they're going so fast you can actually call it a cloud of electrons just going around a central dense particle in the center. So it's a lot like the solar system, right? Where you have the sun in the middle and planets slash electrons going around it. But there's one major difference. In the solar system, it's all disk-like. What I mean by that is they're all planar, they're all going in circular orbits. Whereas in an electron, they're going all around it. So think of it more as a sphere. The orbit of the electron is spherical, right? It's going all around. It's kind of like a ball. Okay, let's move on. So the center of the atom is called the nucleus, where the protons and the neutrons are present. And I like this term, how it's describing it. The nucleus itself is a cluster of two kinds of particles. So it is literally a cluster of two types of particles. You can see the protons, I believe they're in red, and the neutrons are in blue. And that's practically the entire weight of the atom, because the electrons themselves don't have too much weight. Note how the electrons are orbiting around the nucleus like planets around the solar system, right? So it's a lot, very orbital, so to speak, right? Let's move on. Also, I want you guys to note how electrons, they're kind of in these orbits, right? So the two electrons closest to the nucleus, then there are up to 8 electrons in the second one, and there's one in the last one. So notice how there's spaces. It's not randomly zipping around. There is a structure to these orbits as well, which we'll talk about. Taken. Here's an exercise. Can you think of similarities and differences between the solar system and the structure of an atom? Now, one similarity is that how the solar system is arranged. The densest part, the sun, is in the center, and planets are orbiting around it, is a lot like how the atoms work, where electrons are orbiting around the nucleus. But one thing that's different is that the electrons are going around in a spherical orbit, where planets move in ring-shaped orbits, right? They're planar. All planets are in one plane. The solar system, the silhouette of the solar system is a disk, right? If you look at from the side, there's no planet going perpendicular to the motion, right? So can you think of more differences or similarities? To understand the atom better, we gotta understand a bit about what it's made of, which are protons, neutrons, and electrons. Now, there are only two properties these three elements have. It's either they have a mass or they have a charge, or both, you know? Okay. So mass is something interesting. Okay. Now, a proton is very light, so you just associate one proton with one mass, like it's one unit of mass. So if you have two protons, you'll have two atomic masses. 3, 3. Okay. Neutron has the same weight or the same mass as that of a proton. So they have identical weights, exactly identical. Okay. Now, electron is interesting. It has almost nothing. It's very light. Okay. Its mass is about 1 over 1800th of a proton. So it's almost negligible. Even if you have like 100 electrons, that would barely change the mass of a atom. I don't think it goes that far. Okay. Maybe in some elements, but like generally it won't go that high. So it doesn't really matter the mass of an electron. Okay. The other quantity is that protons have a charge on them and electrons have a charge on them. Okay? And neutrons do not have a charge on them. Now, protons, it's in the name, proton, positive, right? They have a positive charge and electrons have a negative charge. And how do these behave? Well, charges do not interact with anything that does not have a charge. So neutrons like out of the game already. It doesn't do anything too much when it comes to atoms. And it's mostly a game of electrons, and protons kind of complement electrons. So that's how an atom works. It's mostly how electrons behave is what we'll be studying. Okay. Now, one thing about charges, just a quick physics recap, is that opposite charges will attract. So the proton is attracting the electron. That's why it stays in orbit like the way it does. And like charges will repel. So a positive proton will repel another proton, right? And an electron will repel other electrons. So like charges will repel, like charges will repel, and opposite charges will attract. So positively charged atoms or protons will attract negatively charged atoms or ions. Okay. So here's a little exercise. So we have two quantities, mass, and you have your, oh, it's not supposed to say nucleus, it's supposed to say neutron. My bad. Neutron. This is supposed to say neutron. Okay. And we're gonna try to highlight what's common between all three, like which of these quantities have masses. So it's the neutron and the proton, right? So these two have the same mass, right? Where the electron's mass is almost negligible. The charge, well, the charge is only shared by the proton and electron. There's no charge on the neutron. Okay. So you can kind of see like protons are the only one with a mass and a charge, whereas electrons do not have a mass or negligible mass, but you call it like, hey, it's negligible, right? You ignore it. Whereas neutrons, sorry for this, it's supposed to say neutrons. Neutrons do not have neutrons do not have any charge, just the mass. Right? Let's move on. What are subatomic particles? Well, that's combined. They form to combine an atom, right? There's the neutrons, protons, and electrons. Name these particles that make up the atom, and I just did. They are neutrons, protons, and electrons. Which particle has a positive charge? Well, it's the proton. Does not have a charge? Well, neutral, right? That's the neutron. Almost no mass? Well, that's the electron. Let's move on. So a proton number. The proton number is just the number of protons in an atom. Okay. Now, proton numbers are unique to every atom, right? Each atom has a significant, like its own proton number. And that's the wrong way to look at it. The correct way to look at it is, if you have one proton, you're just hydrogen. In an atom, if you just have one proton, you have hydrogen. If you have two protons, you're not adding one more proton to hydrogen and giving it a positive charge or anything. That atom is now called helium. Okay, protons don't really change. You can't really add them. So as soon as you have an atom with a different number of protons, it's just a different element. Okay, and that's a good understanding to have. So here's an example for sodium, which has 11 protons and, while to match it, 11 electrons. The electron number will match the number of protons every time for an atom. Why? Because atoms are considered neutral in charge, and their charges on them will need to match, right? So will need to balance out. That's what I'm trying to say. So if it has 11 protons, it needs to have 11 electrons to balance those charges out. The number of neutrons in an atom does not really depend on anything. You could have too many, you could have too little, you know, you could have actually different numbers for different atoms of the same element. So sodium, there could be a sodium with different number of neutrons. Does it affect the sodium atom? Well, almost in no ways except for one, just its weight. Because having extra neutrons will make it heavier because neutron also has a mass, right? And that's it. But we'll talk about that in a bit. Okay. Now the same proton number, because it's unique to every element, is used as a serial number or a registration number for each element, right? Each atom. So if something has one proton, like you literally identify it, and that's what you use to look at atoms quickly on the periodic table. Okay. So proton numbers is kind of like used as registration numbers. You literally use it to identify atoms by using their number of protons or using their proton number. There's a slight bit of confusion when you talk about nucleon number, because I think the sole problem lies in the fact that it's called nucleon, and it's a weird word. What it's trying to say is how many particles do you have in the nucleus? That's what this number is. And what sort of particles do you have in the nucleus? Well, you only have protons and neutrons. So the nucleon number is just another way of saying it is the sum of number of protons and neutrons. Now, why is this number useful? Why do you think? Protons and neutrons are the only two particles out of the three. Electrons barely have any weight, but protons and neutrons are the only two elements, the subatomic particles that that have mass. So they contribute to the mass of the atom. To have them is to know how many protons and neutrons you have. You can realize how heavy that atom is. So for example, over here, you have 11 protons for sodium, and 12 neutrons for sodium as well, right? So each of their mass is 1 each. So you have the total 11 protons are contributing a mass of 11, and total number of neutrons are contributing a mass of 12. So the sum of the masses is 23. So the total mass of the sodium atom becomes 23. Okay. And that's the only use for the nucleon number. You don't actually even call it the nucleon number, you just call it the mass. But this is just here so you don't get confused when someone mentions nucleon number. But aside from that little fact, no one calls it the nucleon number. We just call it the mass. Okay? Mass of an atom. Let's move on. Let's use that proton number to identify an element. There's a element that has only 9 protons can be identified. So if you look at the periodic table, you'll see all of the numbers are going in a series. The proton numbers. Neutron numbers or the nucleon number, not so much. But proton numbers, it's 1 for hydrogen, 2 for helium, 3 for lithium, 4 for beryllium, so on and so forth. And they're going in rows, right? You start with one row, you complete one row, like helium and hydrogen are on the top row, then you start with lithium, and they're all in order. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And if you're looking at a periodic table, you can quickly identify we're talking about this particular element they're trying to talk about is fluorine, which has 9 protons. It has 9 protons. Okay. Why do atoms have no overall charge? Well, the atoms have no overall charge because the number of electrons in an atom is balanced by the number of protons. So an atom does not have a charge. By the way, if an atom has a charge, you don't call it an atom anymore. You call it an ion, right? So, little caveat. Whenever you say an atom, you imply that the number of protons are balanced by the number of electrons. So it's kind of incorrect to say an atom with a charge. It's more like, hey, it's an ion now, right? It's graduated to a higher state. Okay, let's move on. All right, so here are some elements mentioned and their nucleon number and their proton numbers are mentioned. Now, sometimes these values are reversed depending on what question you're doing, and if you're looking at the periodic table, like normally when you write it, this is how you write it, like in text, or whenever you see a question, this is how you see it. But on the periodic table, if you notice, these values are reversed. If you look at carbon, it's 6 on the top and 12 on the bottom. So how do you how do you identify what the proton number is and what the nucleon number is, right? The easiest way is, well, proton number will always be smaller than the nucleon number. Why? Proton number is just the number of protons in an element, where the nucleon number is the number of protons and neutrons in that element. So the smaller one will always be the proton number, and you can easily identify it. So let's identify all the number of protons for each of these. So the number of protons for each of these: carbon has 6, oxygen has 8, magnesium has 12, aluminium or aluminum has 13, copper has 29. And the number of electrons for all of these will match. I want to use green, right? Because they're atoms, they have no charge on them. So how is that they don't have a charge? Well, because their number of electrons are equal to the number of protons. So carbon has 6 electrons, whereas oxygen has 8, magnesium has 12, 13, 29. Stop me if you've seen this before. Okay. And then you have number of neutrons. Now, number of neutrons is slightly tricky to identify. You just need to do a quick bit of math. Remember, the number of nucleons, the nucleon number is just the sum of number of protons and neutrons together. You already know the number of protons. So can I just minus 6 from 12 and find out the number of neutrons? Yes, I can. That's exactly what I'll do. So the top value, what I'm doing right now is the top value, use that and subtract the bottom value from it, because that's the total number of neutrons and protons put together, and I'm just subtracting the number of protons to get the number of neutrons. Okay. And let's do that. So 12 minus 6 is 6, 16 minus 8 is 8, this is 12, I think this is going to be 14, and 64 minus 29. I take 20 away from 64, that's 44. Then I need to take away 9. I first take 4 away, that's 40, then 5 away, 35. So this is going to be 35 neutrons. Okay. Easy? All right, let's move on.